Okay, hi all. I'm Aram Drambyan from Code Signal, and today I'm going to speak about live interviews architecture on AWS. To start with, let's understand what we understand when saying live interviews. Let's define our problem. Our goal is to support live coding collaboration between multiple participants. Similar analog will be Google Docs. I think all of you should be familiar with it. It should be guaranteed that even when simultaneously changes, people are changing, the final picture will stay same for all the collaborators, all participants. And we are going to handle collaboration both for file content and the file system, but it doesn't assume handling the call, for example, what Zoom does or Google Meet does. Only the code change events, only the file system change events. Yeah, and before going ahead, I wanted to say that we have presents for best questioners, so don't be hesitant to ask questions at any point of the talk. And we have a separate question part at the end too. Okay, so continuing the challenge, one of the well-known approaches for solving this kind of task is called operational transformation. It's a separate science. There are a lot of scientific papers related to that topic, so we are not going to dig deep into that logic, but things that we need to note, there are some things that we need to note because they will affect our upcoming architecture. So operational transformation requires a centralized source of truth, source of truth approach, which means that we can't do any kind of stateless architecture. So we should keep state. And the idea how operational transformation is working, it's making the versioning of the changes. And when we are making some change in our client side, the change is going to the server. The server approves the change or kind of merge it with other changes that happened during that time and return as a result, approving the change that we made, or saying how the change should be modified. So there should be some state in the server that will be source of truth for all the collaborators. So taking that into account, we also want to make sure that all that collaboration happens as fast as possible, right? Because it's about typing and coding, and when even multiple participants are typing, we want to avoid some lags and freezes during that process. So we want, in our final architecture, we want to avoid storing that state in any type of database, even in memory DBs like Redis DB, to make sure that processing will be as fast as possible, and also it's very important to process events one by one. That process, the event processing part in the server should be synchronous. So keeping all the data in server's memory is the easiest way, and I also think it's the best approach in this case. As a result of that constraint, we need to make sure that all participants will be connected to the same instance, to the same server machine, so the state of the interview will be kept in that machine and the processing will work correctly. Yeah, and we also obviously wanted to have a horizontally scalable service, and make sure that all servers, all the instances are independent from each other, and crash of one won't affect anyway other instances. Okay, so for our architecture, we are going to use these AWS services. I'll go briefly over them because I guess we have people that are not too familiar with AWS or maybe just don't know a couple of these services. So EC2 Autoscaling Group, as states the name, it's so any cloud service has that base unit, base machines that they use for computing as a computing engine, and AWS call its machines EC2s. So EC2 is just a machine instance, not a container, but a physical instance that you can use. And Autoscaling Group, as name said, it's a group of instances that can be automatically scaled upwards or downwards. DynamoDB is a very easy to use NoSQL database. It has a very simple interface, like not too complicated as MongoDB. Like we will talk a little bit later why we are using specifically DynamoDB. Lambda functions. Lambda functions are one of the most famous things when we are speaking about AWS. They allow you to design like serverless architecture, so-called, when you don't have specific servers, but you have some jobs that should be executed, and Lambda is doing just that. Like when you have some process that will be done, like it's not a persistent job to do, then Lambda is the ideal solution for that. Lambda is just about executing some specific code, like a function, like an API, like a REST endpoint, for example. Yeah, it can do any kind of job. Even like it's very easy to simulate, for example, cron jobs using Lambda. It's just a one-time invoke without state, without thinking about servers and the machines that are invoking that code and executing it. And lifecycle hooks are things more connected to different. It's I wouldn't call it like a totally separate service. It's something that kind of works with other services. In our example, lifecycle hooks are triggers when EC2 instance is terminated, which means it goes down, or when new instance is deployed. And with lifecycle hooks, you can trigger lambdas. More about their usage we will talk a bit later when we'll get to that section. But as a high-level idea, they allow us to trigger lambda functions when instance is launched or instance is terminated. Yeah, so why do we use EC2 auto-scaling group? So EC2 auto-scaling group is, we can imagine it's like our main, the main server of our service. That instances will contain the main logic of the collaboration, and collaborators should be connected to that instance, and the interview will be handled there. So we want to make sure that when we are speaking about one interview, all the collaborators should be connected to that single instance. But different instances will be able to handle different interviews independently. Yeah, anything that I forgot to say? Yeah, like all collaborators will be directly connected to the same instance. So the thing why we are like speaking about this topic separately, why it deserves like a separate talk, I think because AWS doesn't provide any customizable load balancer that will allow you to balance to to forward your message or your request to a specific instance. It has an application load balancer called application load balancer that lets you to balance on the level of groups. So if you have multiple EC2 groups, for example, you have one big service that can be divided into separate two sub-services doing job A and doing job B, then you can use that balancer to balance between the two groups. But we need to understand that each group can contain multiple instances, so it won't work for our case. And other balancers are even more restricted or have similar restrictions. So the normal load balancer won't work for our case. So we are designing our own custom load balancer. We have to design our own load balancer. And for that, the idea is to somehow create that load balancing mapping from the clients to the server that will handle the interview, and make sure that even client reconnects or rejoins to the interview, he will be again reconnected to the same instance, and new collaborators will also be redirected to that instance. So we need to create that persistent connection for all the collaborators. Yeah, like going back here, also just let's note that in case if you are interested, we are using WebSocket connection between client and server connection, because both client can send changes to the server, and when other collaborator makes changes, that also should be published to all the participants. So WebSocket connection fits perfectly for this case. Yeah, and to store, to create that connection and store it until the interview ends, we wanted to store that information, that mapping data somewhere, and for that we decided to use DynamoDB because it's very easy to use, NoSQL database, like without any hard or tricky parts. Like I think it's like really good design for such use cases when you won't have a very big database, and AWS handles all the clustering stuff for us. It's very easy to configure, easy to use. So it will contain all the data about our sessions. So by session, we will understand that we will have some session ID that corresponds to the interview, and also the instance ID, the instance that is going to handle that interview. And DynamoDB will store that pairs. And it's a many-to-one mapping, meaning that a lot of multiple sessions can be handled by one instance, but if we are speaking for one specific session, it will also be handled by one instance. It can be split between multiple instances. So, and also, when thinking about scaling, auto-scaling group provides default scaling logics based on CPU utilization, memory utilization, network utilization. But that's not always the case. Like, it's not the best way of understanding when we need to scale and when we don't. So we can very easily implement our own custom scaling logic by just adding a couple of endpoints and lambdas. AWS supports that, and it's very easy to do. And for that, we can use our own data, and it will be very natural to do scaling based on the number of sessions, for example, or or some limits based on the session, based on how loaded each session is. So DynamoDB will also help us kind of to store the data for scaling if needed. Yeah, speaking about lifecycle hooks, yeah, as I mentioned, we have two types of hooks: when instance is launched and instance is terminated. So to be able to do that much, yeah, let's keep that matching part still in a black box. We will kind of speak about it right in a minute. But before that, we also need some to be able easily fetch that data of what instances do we have, what instances are available, and we always want to keep that data in sync. So we decided to also keep that available instance IDs in the DynamoDB, and lifecycle hooks are a lifesaver for that case, because when instance is launched, we are adding the data related to that instance. It's not always only the instance ID. It can be other data if necessary to the DB, and on instance terminate, information about the instance that is going to be shut down will be deleted from the DynamoDB. Also, very cool thing about lifecycle hooks that they are triggered right before the instance is launched, and if something goes wrong during that Lambda execution, the instance won't be launched. So they also give us extra safety that we can make some checks if everything like code was deployed and is running successfully. We can make sure that there won't be corrupted instances running, or like semi-configured instances running. So it's another good step to make everything like protected and secure. And finally, the Lambda functions and how we use them. As mentioned in the previous slide, Lambdas are used for lifecycle hooks. Also, that matching is performed, that load balancing we decided to perform using Lambdas. Because what we need to do is match interview with a session, and it's a one-time thing. Unless, for example, the container crashes, and then we need to move that session to another instance, but that's a different story. Like to keep things simple, let's think that we need just to match a session with an instance, and it's a one-time process. And Lambdas are, I think, pretty perfect design for this. We just have a Lambda that performs that custom load balancing for us, creating that mapping and storing in DynamoDB. Also, thing to do, we always need to clean up after all the expired sessions, and another Lambda that is just cleaning up the expired sessions, which means all the finished interviews. am I speaking too fast or maybe skipping some important points? Any questions so far?
Yes, Omar. Isloadnek van zermot, ez milyen zsámanek kan user a maximum az is arra meszpány.
Yeah, good question. I'll just translate in English just in case if you have foreign listeners too. The question was how many, how big is our load currently and how many participants do we support? Just to clarify, when saying participants, you mean for one session or how many multiple sessions we can support? How many multiple sessions we can support. So the current load differs, like it can go high until 1,000 interviews, for example, at the moment. But the number, we have guessed that the number will significantly increase in the near future. So this kind of having a scalable logic there makes maybe it was not too important a year ago, but now it's becoming a crucial problem for us. And it also differs from time, depending on the hour. For example, it's based what is the time zone that your clients are working on. For us, it's mainly US time zones. So, but the peak is about 1,000.
And what happens if one instance is crashed and there were some interviews?
Yeah, so, yeah, that's a good point. I decided to not cover that part in this topic to not make things too overcomplicated. But as a fast answer, the thing that we can do, we can have a memory database that synchronizes all that in-memory state every second or every 2 seconds. So we are keeping cache of the interview in that memory database. Why memory database? Because it's easy to use, it's fast to use, and is designed for cases like for caching, exactly. And when container, just to finish my sentence, and when the instance crashes, we are finding a new instance that will handle the session and continue from the point that we have cached. The worst case scenario, we will lose 1 or 2 seconds of coding, which shouldn't be a huge loss during the interviews.
And all instances are coupled to that memory DB, Redis somewhere.
Yeah, separate DB. It can be even DynamoDB, I guess, but probably something like Redis separately running. Also can be on AWS because AWS has a support of Redis DB on its own. So you also won't be, and it even have a very private memory DB for a private network. So you won't worry about any security or vulnerabilities. Yeah, and also about scaling and clustering of that memory DB. Yeah, and after talking about this services separately, let's see the whole picture altogether. I hope it's visible for people even from that are sitting a bit far away. But if you don't see anything, feel free to ask. So the design is that we have collaborators, in this example, collaborator 1 and collaborator 2, our client sites. They are opening interview in their browser, and they are using this Lambda to generate for them or return, if it's already generated, return for them the instance ID. Not instance ID, but the instance information. It will be the DNS to use the domain to connect that will handle their session. Then they directly connect to that instance using the given information, of course with some authentications. And here under the hood also we have lifecycle actions on instance creation and instance termination. The data about these instances will be updated in another DynamoDB table. That will be used by this Lambda to do the match. So this is the combined picture of all that I was describing before. And I also want to speak a little bit about services that they don't impact the architecture a lot on their own, but they were helping a lot in different areas like deployment, maintenance, and I think AWS experts will be very familiar with these services, but I think it can be very good information for people who are not too familiar with AWS, and things to consider for people who are kind of starting their journey with AWS. To be honest, this is like my first project with AWS, and I think that, it would make our life easier if we knew about this like at the beginning. So sharing that experience with you. First of all, Secrets Manager. It's an AWS service that helps you to manage all the secret credentials like database accessing link or like other type of credentials very easily. And it also supports like updating, changing, refreshing all that credentials every hour, for example, like every n times that you can kind of fix on your own. It helps us to avoid storing any type of that credential in code or in our environment configuration variables. So we can kind of store all that in Secrets Manager, give our service only access to the Service Manager to talk, to get the data, and our service will get and use it. Also, we can make sure that it will be changed every day, for example, that credential, and and AWS makes sure that our service will always get the up-to-date credential to log in, to get access. So it's very helpful when you want to encapsulate all that credentials. Code deploy. So one of the cons with our solution is that we are like using EC2 auto-scaling group, which is, for example, compared to ECS, requires more maintenance on its own. It's not containers, it's just machines that require some maintenance. And code deploy helps really, really a lot by decreasing that maintenance part significantly. Code deploy requires you to, with one YML file and a couple of scripts, to write the full setup logic for your application and for your service. Like the scripts will be executed when, like before installing dependencies, after installing, not installing dependencies, before install, after install, how to run, how to stop the instance, and also it helps to make the deployment process as fluent as possible, supporting different type of deployments. Like one by one, or first part and the second part, or blue-green deployment when you are deploying the new version while keeping the old one and then switching everything to the newer version. And also have a very good fallback logic support when deployment fails, for example. So it makes everything like deployment more secure and easier to do for engineers. Also, thing that I want to mention, AWS roles. AWS lets you to configure roles as precisely as you want, to the moment where you can like give some services access to a possibility to invoke only specified Lambda functions, like which is a dream for a perfect encapsulation perfectionist like me. So that was all that I wanted to talk today about. And we got to the part of questions. Yeah?
How are you solving race conditions when two users exactly type the same text in the same position?
Yeah, so to handle that's why they are kind of, that's called one approach to solve issues like that is called operational transformation that I was saying. It's something that requires separate topic, so that's why we don't cover it here. It's some scientific research, different approaches, like proving that the concept is correct. It's all done by the logic that brings us to all the restrictions that we were trying to solve today. So it brought us to the restrictions that we want to have state. We want to have state in memory of the instance. Did I answer to your question?
Also, why not using private own cloud instead of AWS? what's the main benefit?
So yeah, if you wanted to use private on cloud, it requires a lot of maintenance. It requires a lot of initial money to be able to build that private cloud, right? You mean building everything, the machines on your own?
I mean that AWS isn't cheap. You must pay for each running hour and also using all the memories and all the resources. I mean, is it somewhere a time when you need to build your own because the AWS is too expensive?
Probably, but not now because you will also will have to have a team to maintain everything, while AWS kind of has all the services that kind of make it possible for the engineer even to do the maintenance.
So the main benefit is lack of support, so you don't need to.
Yeah, you don't need to have a team. Also, the initial investment, as I mentioned, is very huge when building our cloud over AWS. So right now, because like our usage is not too big, AWS like works perfectly for our use case. Another question? Yes, sorry, that was a question. Yeah.
Did I get it right that you are using some kind of a custom auto-scaling strategy, yeah? And you're using DynamoDB, like you store there, for example, amount of current interviews, and based on that you scale the infrastructure.
Yeah. That's
my question is, have you considered using for this, let's say, metrics that you store in DynamoDB, CloudWatch custom metrics? And if yes, why did you decide to go with DynamoDB?
So yeah, that's a good point. The part with the auto-scaling is something that we are still considering, because as I mentioned, we were not too familiar with AWS, and yeah, the thing we heard about the CloudWatch, like all these investigations in general takes a very long time. We spent a little, like we spent more time trying to find alternative solutions that time to finding this one, just to make sure that this solution is pretty good. But yeah, for scaling, we also wanted to make sure that the maintenance is minimal from our side, and we are still looking for a better thing to use, because it's not a bottleneck right now. Just having availability to even hard coding 5 instances is enough for our current use case. But yeah, we wanted to automate it as much as possible, and that's a good point. Thank you.
I'm not a user of AWS, but I want to ask, why don't you use another like cloud with like batch load balancing instead of like AWS load balancing, which is faulty as I understood?
Yeah. So I think the easiest answer is that the consistency with other services. When you have your app deployed in different cloud services, it's harder for the business because big companies require all the data, they want you to be secure, and having everything unified is pretty good. And taking into account how many services AWS provides and how easy it is for the new engineers to kind of learn AWS, we decided to stick with AWS.
Can I ask another thing? So, for example, I'm doing DevOps and DevOps. And best practice is saying just use every single service, whatever you like from different clouds, and for example, like use Terraform for maintaining your infrastructure.
Yeah, so we need to finish, but I'll briefly answer to your question. We are using code infrastructure as a code philosophy, despite that everything is on AWS, but we don't have it's also based on the limitations of your team, how many team members you can afford, what kind of team members you can afford. So right now, because our team is not too big and we don't have all that different specialists together, this is, I think, was the best way for us to do it. Okay, thank you for all your questions. Unfortunately, I forgot to bring the books with me, but I will ask you to come to near our desk at the 3rd floor. So I'll give you the presents, and I decided to give presents one to you, and the second one, okay, I think the participant that I was thinking to give left the room probably. So the next winner, I think, will be you. Okay. Thank you all for the questions. Thank you.